Yes, children, see the concept of decimal expansion of rational and irrational number. So, if the number is rational number, if it is in the form of p by q, q is not equal to 0. If the number is a rational number, then either it has a terminating type or non-terminating repeating type. Its decimal expansion is either terminating or non-terminating or repeating. Non-terminating and repeating type. Okay, and if it is irrational number, then its decimal expansion will be of the form non-terminating and non-repeating also. So the digits will not terminate and they are not repeating also. Okay, now if x is p by q, if x is a rational number, it is of the form p by q and q is not equal to 0. So this is a rational number. Then prime factorization of q is of the form q is equal to 2 to the power n into 5 to the power n. Means if the denominator, q is in the denominator, so denominator is of the form 2 to the power n into 5 to the power m, where n and m are the non-negative integers. So they are non-negative integers. They are either positive or it can be 0 also. So they are non-negative integers 2 to the power n into 5 to the power n. If the denominator can be expressed in this form, then the number x has the terminating decimal expansion. Okay, so this x has terminating decimal expansion if the denominator can be expressed in the form of 2 to the power n into 5 to the power m. Okay, and if this rational number x is p by q, q is not equal to 0, if the denominator q, prime factorization of this q is not of the form q is 2 to the power n and into 5 to the power m, where n and m are non-negative integers, then x has non-terminating repeating decimal expansion. Means it is non-terminating and repeating decimal expansion. Understood the difference between terminating, how to identify the terminating and non-terminating? If q can be expressed in the form of 2 to the power n into 5 to the power m, okay, then x has terminating decimal expansion. And if it cannot be expressed in the form of 2 to the power n and into 5 to the power m, so q cannot be expressed in the form of 2 to the power n 5 to the power m, where n and m are non-negative integers, then x has non-terminating repeating decimal expansion. Okay, then see this example. First example of question number exercise 1.4, question number 1. The number is 13 upon 3125. Here we have to check whether the number has terminating or non-terminating decimal expansion. So we'll check the denominator. Here the denominator is 3125, 3125. So q, this 3125 can be expressed as 5 into 5 into 5 into 5 into 5. That is 5 to the power 5. Okay, now there is no 2. 2 is not the factor of the number q. Okay, that is 3125. 2 is not the factor, but we can write it as 2 to the power 0 into 5 to the power 5. So 2 to the power 0 is 1, 1 into 5 to the power 5, 5 to the power 5. That is, it can be written in this form, 2 to the power n into 5 to the power m. And if we compare the indices, we get n equal to 0 and m equal to 5. Okay, so n is 0 and m is 5. They are non-negative integers. N and m are non-negative integers. Hence the denominator is expressed in the form of 2 to the power n, 5 to the power m. Okay, therefore the number 13 upon 3125 has terminating decimal expansion. So in this way we can check whether the number has terminating or non-terminating repeating decimal expansion. Then the next example. In this example, 64 upon 455. This is the rational number. We have to check whether it is terminating or non-terminating. Okay, so let us check the denominator. This denominator 455 can be expressed in the form of 5 into 7 into 13. Okay, these are the factors. Prime factorization of 455 is 5 into 7 into 13. Okay, now this 5 into 7 into 13, it cannot be expressed in the form of 2 to the power n, 5 to the power m, because the factor is 7, factor is 13, 13 is the factor, 7 is the factor. Okay, so the factors are other than 2 and 5, and hence this number has non-terminating repeating decimal expansion. Okay, so in this way we can find whether the number has terminating or non-terminating expansion.